Now let us come to the main topic. What is a function? Let A and B be two non-empty subsets and F is a relation which associates each element of A with a unique element of B. Then F is called a function from the sets A cross B. Now let us understand what are the main points that are associated in this definition. One is each and every element of A must be used. That is very important. And the mapping should be done with only one unique element of B. That is, one element of A should not be mapped to more than one element of B. So there are two conditions imposed. If you look them clearly, first is every element of A must be mapped and every element of A must be mapped with only one unique element of B. Right? Let us see the definition in detail when we do the examples immediately now. But before we go further, let's learn about a very important notation. A function f from A to B is denoted in the form, you will come across this notation very frequently. F from, this symbol is for from A, from the first set to another set B. And this is read as f from A to B. Okay? Now, by the definition, if you look at, a relation is a subset of A cross B and a function is a subset of a relation. So function is a subset of Cartesian product. This is very important observation. Next, for all A belongs to A, remember the definition, each element of A, that is each and every element that is present in A, for every A belongs to A, there is an f of A such that the order pair A comma f of A is an element from A cross B which is a superset of F. Then if A and B belongs to F, A is mapped to F and A is also mapped to F. Now look at this. Each element of A has a unique element in B. That means, but A is mapped to B here and A is mapped to C here. Then A cannot have two different elements. Therefore, that elements B and C must be equal. So if you look at this part, this says every element of A must be used in the mapping. And the second condition says the element which is mapped should have a unique element in B. Then the relation which we selected F is called as a function. So this is the definition in words and this is the mathematical form of definition. Right? Now let us see here. Identify which of the following relations are function. Is this a function? If you look at the definition, every element of A must be used. But if you see, observe here, D which is an element of A, the element D which is in set A is not mapped or not related. So is this a function? This is not a function. This is not satisfying my requirements for a mapping to be a function. Let's see another case. Here, all elements of A are used. The first condition is satisfied. But if you look at, A is mapped to 1, B is mapped to 1, and C is also mapped to 1, and D is mapped to 3. Is it violating any relation? All elements are mapped, and no element is repeated in the mapping. Therefore, is this a function? Yes, this is a function. The relation F2 is a function. Now let us see one more. Can I call this relation as a function? Let us check the first condition. Is every element of set A being mapped? Yes, A is mapped to something, B is also mapped and C is also mapped. But if you look at the mapping, A is mapped to 1 and A is also mapped to 2, then what does our condition for mapping says? 1 should be equal to 2, which is false. Therefore, A, which is the element in the first set A, has two different images, 1 and 2. Therefore, F3 is violating the second condition of a function. Therefore, F3 is not a function. This particular three examples identifies one case where the relation is not a function because of the failure of first condition. The third example explains the reason why F3 is not a function, which is a violation of second condition for a function. And F2 is a function which satisfies all the required conditions of relation to be a function. Right?